I wanted to take a minute today at the beginning of the podcast and say thank you to our sponsor, Huber Engineered Woods. Huber has actually been a sponsor of the podcast since 2020 when we decided to start this little endeavor. Without our sponsors, this content is probably not something that happens. But I think the best part about having Huber as a partner on this is it's an incredibly authentic alignment. Peter, Steve, and I all use Huber Woods. I've been using Advantech Subfloor for coming on probably 21 years now. I've been using Zip System and Zip System with the insulation on the back, the Zip R, since 2013. It's a system that I believe in. That systems approach where things play well together. They have design parameters that allow you to use their system for what you're working on. It works. Their tech support's there. Their knowledge is there. I've never had an issue with their product, and it's a great thing that they've decided to sponsor the podcast. So thank you, Huber Engineered Woods.
Welcome to the Unbuild It podcast. I'm Pete Yost, your host. I got my best buddy. Jake's going to be insulted. Steve Bazik here.
We'll get over it. You didn't say my name right.
Well, are
you serious? I'm my best buddy, and you can't say my name right?
When I say your name into the microphone
Good start.
For Siri, I have to say Baczek. Otherwise, it doesn't pull your name up. So that's not a very good reason for why I mispronounce your name. But you're now allowed to call me Peter Yost whenever you want.
Man.
Wait, right. I wrote this. This is not a good start.
Yes.
We got Nick Sabol here from Huber Engineered Woods. Nick is on the technical and engineering teams at Huber, works on product applications and development. And it's good to have you back for another Q&A.
It's good to be back.
All right. So the first one, I got to put on my glasses for this. We're going to talk about, this is from a listener, and it...
well, that's good.
It's Nate. Rainscreen in a fire zone with low rain, ? Should I? Appreciate all you guys do except Peter. That's why Jake gave me this one. Hey, we're in climate zone 6 in the mountains that average 15 to 20 annual rainfall. Most of our moisture comes from snow and subsequent runoff from higher elevations. We've been discussing rainscreens on our builds with both internally and external sources. The concern is that the rainscreen would allow an opening for wind-driven embers and access point to facilitate fire, potentially in an assembly that the fire would not be visible until it's too late. Discussed this with Huber at IBS. They advised they had not done testing on this and couldn't advise to use their products. They also advised that given our low rainfall amounts, it was probably unnecessary for a rain screen at all. What do you think? Also, in transparency, it's probably a smaller concern than our customers actually view it. Population density versus wildfire prevalence. But with the recent high profiles in Hawaii, LA, it has become a hot topic with our customers. Thank you again. I guess thanks to Peter also. Wow. That's a tough way to start a session. But okay, so we do get this question quite a bit.
Yeah.
That if you create a rain screen, it channels great for air, for water coming down and for air moving up and through. But what about wildfire?
Yeah, and we've learned a lot since IBS last year.
Cool.
This question started to come up obviously when we launched and had some success with the Zip System rain screen. And I remember speaking with Ken Hicks. He's what we call our code guru.
Yeah, we've done a lot of work with Ken.
Yeah, he knows. Not only is code is his passion.
Yeah,
he knows his stuff, and he always has the answer. And he directed me towards a document. It's an ICC document. It's called Harmathy's 10 Rules. And I don't know the document well enough to speak about all 10 of them, but I do know...
Could be a resource.
Yeah.
You could see me already writing it down.
Yeah.
Harmathy's
10 Rules. It's a very strange title for an ICC document, but it has the stamp at the bottom and everything. And I believe that it also appears in another document that I can email you as a resource. But the second rule is that fire endurance does not decrease with the addition of additional layers. So I think that is one thing that we have going for the performance of drainage mat products. And then the fourth rule is, and I wrote this one down because it's a long one, the further an air gap cavity is located from the exposed surface, the more beneficial is its effect on fire endurance.
So we're talking about if there's more distance between ground level and where that cladding starts, basically, that's the space he's talking about?
I'm not sure if it's that or if it's where the fire is located on the vertical side of the wall assembly.
Oh, okay.
So, again, there's a little confusion with this document, and I'd urge you to check it out. But this is one of the documents that we've been directing folks to when they have these questions, because when it comes to wildfire and fire performance, it's, no pun intended, a little bit the Wild West when it comes to rain screens.
Steve, have you done rain screen details in wildfire zone areas? And how did you do them?
Like normal.
Like normal?
Mm-hmm. So you want me to be the pragmatist on this question?
I think so.
Okay. Have either of you seen photos of Hawaii after devastation?
At Maui?
Yeah. Have you seen? Do you really think a rain screen made a difference?
Yeah.
No.
I mean, there's things we could talk about because we need to, and there's things we talk about because we can.
Yeah.
This is something that we talk about because we can. If 3/8 of an inch makes a difference in your house being successful or not successful in a fire, I just don't see that as being a situation ever.
Well, my mind goes to brick. Brick veneer has a code required 1 inch minimum air gap, right? Mm-hmm. Brick houses have been around with that 1 inch air gap for a very, very long time.
Yeah, but the brick is what's saving it in the fire, not...
Right. Because the weep poles aren't big enough for embers and brands to get up in. And Steve, that's where, I remember our buddy Steve Quarles, who was a researcher and came to some building science summer camps because he is the wildfire guy for the state of California, or was. He's retired now. But he also worked extensively with IBHS, which is the Institute for Business and Home Safety. He said there are details that you can do at the bottom and top of the wall, like a heavier gauge metal screening.
Do a bronze screen. I mean, we've done green screens with bronze screens at the bottom and such.
And because the issue is that if brands or embers that get blown, so we're not talking about the whole fire approach in the house. We're talking about brands and embers that can come up against it. That's like a point load of fire potential.
Sure.
And all it takes is some protection to keep that brand or that ember out. That allows you to have that and not have that be a transfer chimney for the fire spreading between your cladding and the rest of the house.
We would need to have pressure pulling that into the wall assembly too, right? In this instance, it seems as if the question involves an ember being sucked up into the drainage space that is causing fire.
And I think what happens is if a brand or ember comes up against and is leaning against the bottom of the building, and then little tiny sparks come off of that, and they're going right up behind.
Sure. Okay.
That's the issue.
Yeah.
I had a project in Portola Valley where, in addition to doing a metal screen to protect that space,
he's under the assumption I know where the hell Portola Valley is.
I pretended I did.
You pretended you did. Better job than Steve. It's just very close to Stanford, University.
Sure.
Portola Valley.
Portola Valley.
Gotcha.
So a lot of wildfire potential with homes built right on the side of, vegetated hillsides. We added an intumescent paint to the bottom. So that intumescent paint, if the temperature gets high enough, foams and closes off the gap. Okay. And then after the fire is over, you just scrape off that intumescent paint. That was the idea behind that. So I agree with you, Steve, that if it's a wall of fire approaching the house, that's a little bit different than these leading embers and brands that we're concerned about.
So I got my fire guy. I'm not going to tell you who it is, but he's wicked smart.
Oh, okay.
In fire guys. And our conversation went such that he thinks the speed of the fire is very, very important to the success of the surroundings. Because he said that if you have a wildfire that kind of blows through like the wind, he said that's probably the better condition. He said, you have the wind, which means it's spreading faster, but it's going to blow by everything. If you don't have that and you just have one that's kind of feeding off of the ground, his comment was that you don't need the fire. The heat is going to be so intense around that fire that your house is going to just internally combust. Something in the house is going to burn.
Yeah, I think we can agree that there's fire conditions where, even in the best of circumstances, going to challenge that house.
I think there's probably no less than a dozen things you can do before you have to worry about the rain screen. That, I don't know. I don't see it as, if the rain screen is the problem, then your problem's bigger than the rain screen itself, right? Your house is burning down. Sorry. I feel for all those people, certainly, but it's, you build in a place that has wildfires, then you need to, have the surrounding areas cleaned and all of that good stuff, and, create your own little private WUI zone. And
I think that's a key part of this is making sure that you don't have the ability for this to exist in the first place. I think I agree where the rain screen system is just a small potatoes in the grand scheme of this conversation. Now the other half of that is interesting. In low moisture, would you still implement a rain screen system in a low moisture area?
Well, it's still, it's not a lot of rain. It's, what do you say, 10 to 12 inches?
He said 15 to 20, I think.
Okay, mm-hmm. So that's, half of Seattle.
Yeah.
And the question is, though, with rain, you're going to love this, it depends on when it comes, right? Because if I'm getting 10 or 20 inches over 12 months and I'm getting, an inch and a half a month, that's one thing. Yeah. But if I'm getting 10 to 20 inches in 3 months, then that means that area is acting like Seattle for 3 months.
Mm-hmm. Yeah.
And
in both Seattle scenarios, I think it's beneficial to have. Yeah,
I never see the downside to the ability to drain and dry. I just don't in a wall system.
We also have had some folks comment on the fact that they don't do drained and rain screen systems for rain. They do it for poorly installed irrigation systems.
Oh, wow.
Where it's pretty easy to find photographs of irrigation heads that are irrigating the building as opposed to irrigating the landscape.
I did one house where we put fire sprinklers in the soffits. So basically, if there's a fire, the homeowner can go downstairs, throw a valve, and the house gets a shower.
The house gets a shower on the walls, but not the roof?
Not the roof.
Yeah. There are also systems that are set up to basically sprinkle your roof system.
Yeah.
Wow. And they're quite popular, and they're not inexpensive, but they're there to protect the structure. Now, you can still find a fire that would overwhelm that, but it's just more protection.
Well, it's kind of like building a house on the, coast of the ocean and then crying that I lost my house in a landslide. It's like, well, you build on the coast and on a cliff.
Site conditions.
When your house goes down, who's to blame? Yeah. You decided to build there.
So I think we've got some pretty good resources to help folks with this question. Mm-hmm. I think that the question of whether or not you need to have it there, in this case, you're doing a bit of balancing because there is the potential for firebrands and embers and sparks to get behind there. Mm-hmm. But did you need to install it to keep the wall from getting wet? So
I think there's other benefits that rain screen systems provide. You have a cooling effect in warmer areas if that's the case. There's more. It's more than just managing bulk water.
Yeah.
That I think makes them worth it. That's why we're seeing them being used in all different styles and forms and places on the structure as a whole, not even just on the wall now.
So I think that we've answered Nate's question, and we're going to move on to zip orientation on a house in South Dakota with Josh. Guys, thanks for producing the show. Your high-quality content is huge encouragement, especially for someone like me who's still working toward building for performance and durability. I'm in East Alabama. That doesn't fit, does it, for South Dakota?
Hey, he's on a roll. Currently
employed by a production builder. I recently watched the Build Show series on the Mitchell House. Oh, the question is about the design that Steve did and built by Josh. I was particularly impressed with how the zip sheeting was extended over the top plate before setting the trusses. However, I noticed the green side of the zip sheeting was facing the conditioned space rather than the attic. So the polymer was faced down.
We just use that as a little flap.
Could you clarify why this orientation was chosen? Is it related to vapor control, ease of installation, or perhaps climate-specific factors? Does the orientation matter in this context? Greatly appreciate your insights. Great. I think that's where we stand. So the question is...
Well, the question is, do you want Nice Steve to answer this question, or do you want me to rant?
Can you do both?
No.
No.
You get one or the other. It's Dr. Jekyll or Mr. Hyde, buddy.
There's no nice rant.
No, I can give a nice answer.
Yeah.
Okay.
I'm disappointed we can't do both, but have at it. What's your preference?
Well, first of all, let's get one thing straight. Every material is every control layer. We need to stop, like, is this a vapor barrier? Is this zip sheathing? It's a structural panel. It's an air barrier. It's a weather resistive barrier. It has vapor permeability characteristics to it, and it has a thermal property. It sucks as a thermal property, just the 7/16, but it doesn't mean it doesn't have a thermal property.
So is this, we're getting the rant, right?
We're getting rant.
Nice.
So
Buckle in.
buckle up. Yes.
Yeah,
Buckle up and put a helmet on. That's my latest favorite quote.
Nice.
Life is hard. Wear a helmet.
Wear a helmet. Yeah.
Exactly. but we need to really stop. Like, we have been doing this for well over 30 years.
Yeah.
And we get the same stupid questions. This isn't a stupid question, but we get the same stupid remarks like, what is the vapor barrier? Well, all three of these materials are a vapor barrier. This one's just better at it than these other two. And that's our primary one, and then these other ones. So when you look at zip, and when I'm detailing a house, I'm looking for, okay, I need a material that has a certain property. Okay, on the outside of the wall, I need a really good air barrier. I need a structural sheathing. I need a weather-resistant barrier. Bang, zip goes up. And I can tape it. I've accumulated all three of those properties very, very successfully, and extremely successful there because we tested at 0.18 on that house.
So let me just say, are you saying that the reason you put it face down...
I didn't get to that yet.
Okay.
I'm telling you why I used it on the wall.
Oh, on the wall. Okay.
So now when we look at it, we have our slab, we have two walls, and then we have a ceiling. Slab is done. Integration to the walls is done. Walls are satisfied. Now we have to move on to the ceiling. I have to connect this to that. And I'm showing my wall hand and my ceiling hand.
Yep.
Something has to turn the corner there.
And that's a really important corner because it's at the eve where there's a lot of air leakage.
And the thing that's even more important is it has to turn the corner before the trusses go on. And I can't make the connection on the inside until the trusses are in, right? Because whatever air barrier I'm putting on the inside, it's probably going to be connected to the trusses. So I need to put something there that is, I won't say temporary, but something that's kind of in sequence, right? Put the walls up, put something up, and then put that. So in talking about what are we going to do for an air barrier in the attic? Well, we talked about, do we do a membrane? Do we do zip? Believe it or not, the zip priced out relatively about the same as the membrane and all the taping and everything that goes with it.
Interesting.
Right? I was surprised, but it just does. So whether you believe it or not. So they said, okay, our framers put up the roof trusses. Our framers do the wall. In this case, it was Josh, but we're doing another project very similar. And it's like, why not just have the framers stay there for a few extra hours and put zip on the ceiling? Okay, so I have zip on the wall, zip on the ceiling. I need to figure out how do I make that connection. So let's take their 4-foot sheet. Let's take it and rip it to 3 16-inch pieces. My wall is 10 inches. It'll extend inside 6 inches.
The interior.
And so now I nail that up. I have that flap, and we set the trusses on it. It's highly durable, right? You can slide the trusses up and down the backside of that OSB. I don't give a damn, right? I tape all of the joints. I tape that horizontal joint. Now I'm connected wall to flap. Set all the trusses. I come in, I put the zip on the underside, and I simply tape it off exactly the same way as I do the wall. Now, the reason it faces on the inside is because that's what the tape is designed to adhere to.
Bingo.
So I flip it over. It's not dealing with vapor permeability or anything. It's an air barrier at the ceiling.
Yeah.
And it's going to slow the moisture migration into the attic, but I don't care. We have 2 Zenders in the house.
Mm-hmm.
So if I'm controlling the relative humidity inside the house and the conditions, which I should be doing anyway.
So you simply used the zip because it gave you properties for an air sealing detail at the ceiling of the building, and it was price competitive with another common way of air sealing at the ceiling, which would be a smart vapor retarder.
And probably the biggest one was the familiarity of the product. Name another product that a framer is more familiar with than Zip.
And so it wasn't there for structural properties. It wasn't there for water management properties. It was there for part of the air seal.
It's like
but you know what? It's better to be lucky than good, because it did have some structural properties to it. Because when Josh went upstairs to insulate, and when we typically insulate, we put the membrane up, we put 2x4s on 16-inch on centers to help hold the insulation. But now we can nail that zip. He was able to walk across the attic and not worry about falling in.
Very interesting.
And, you know, that attic probably, I bet you it has about 6,500 pounds of insulation.
Insulation on it. So also, when you do a blower door test and you have to separate the vented attic from the space, if you use that membrane, I've heard that, you know, that it's certainly a stiff panel like the Zip would make it so that you don't care to what level you depressurize with the blower door.
Exactly.
I've heard that can be a bit of an issue with the flexible membrane.
Yeah, we use a lot of the Sega products. So they have the Twinette tape, which is the double-sided tape that you put underneath the trusses. So then you install that, then you staple it, and then you tape it. It's a pretty formidable installation.
Yeah. Okay.
We've never had a problem with it. But every one of those tapes, and you know, it's really interesting, because when I hear other people talk about different assemblies, they say, oh, you should do this, you should do that. You know, you should put 4 inches of rigid insulation on the outside of the wall. You never hear them speak about the $10,000 worth of screws you have to purchase to put that 4 inches.
Part of the package.
It's part of the package that people neglect. Oh, what's the cost of insulation? Yeah, the screws are half the cost of the insulation on that package deal. And so you just have to be prepared for that when you're making those kinds of trade-offs.
On this project, Steve, did you hold off the interior partitions?
Yes.
Okay, so that's another great advantage for slapping up these sheets.
Yeah, and it's, you know, this gets into, and I'm sure you've heard me talk about, I know you have heard me talk about this, but this gets into the whole idea that an architect, I believe, is a person of integration. There's a lot of architects out there that believe they are people of application. Mm-hmm. Right? So when I design a house, I'm designing I might be laying out the floor plan, but the kind of back of my mind is turning, okay, the air barrier, I'm just going to run it up the wall. I'll run Zip across there. We'll hold off on the interior partitions because it's a 22-foot wide building. Mm-hmm. So we don't have to worry about that. If it was a double loaded building, meaning you have some kind of beam down the middle, then it's like, okay, how do we do that? But that would be pretty easily solved for, in that we would just frame whatever bearing wall and we would put a 12-inch piece of Zip on the top of that before we hit the trusses, and then fill in both lanes.
So like you had a lip on the exterior walls, you would have a lip on the
You just have one that's on the midside. We just did that on a project.
You're using the Zip here as like a segue to your interior air barrier. It
is the interior air barrier.
Okay.
But that's my whole point, is that we need to really get out of this idea that Zip is an exterior sheathing.
Yeah.
And Sega is a smart vapor retarder, and you know, this and whatever the things are. We need to start looking at material. When I look at materials, Zip, yes, it's an exterior sheathing, but to me, it's a hard sheathing with a weather resistive coating that has a tape application that can become can have very good air properties. Mm-hmm. So I just have in the back of my mind a series of materials, and when I look at them, I try and understand what are all their properties. Mm-hmm. And then I do a detail, and the detail I come up with, okay, I need these kind of metrics. So I go over to my database and I say, well, here's a material that fulfills those metrics.
Yeah.
And in this case, Zip was a really good air barrier.
And we get questions like this frequently. I don't have the design experience that you have to be able to make that decision. And it's hard sometimes to answer these questions on the phone. It's very common that we get questions about how to
Especially when you got some jerk like me out there doing all this crazy stuff, and then people call you for the answers.
I'm like, well, did you try calling Steve? They're like, no, he didn't answer. Yeah. Answer your phone.
Steve currently does not have an 800 number.
That's right. Yeah. We get a lot of questions at the top of the wall when it comes to maintaining your air barrier continuity there.
Yeah. Exactly.
And unfortunately, kind of like the bottom of the wall, there's a lot of ways to do that the right way.
Yeah.
Yeah.
So part of the question was, before we go there, Steve, when I was a builder, I didn't even know that there were different properties and materials that we should consider, in terms of can they contribute to any of the control layers? Didn't even know control layers existed.
Yes.
So what you're doing is you're saying the fundamentals tell us we have to make continuous these 4 control layers, but ollie in free for how you do that. And so because Huber and the rest of us have set it up, it's a structural panel. And your attitude is, yes, it is a structural panel, but it's a lot of other things too. It may not do everything as well as being a structural panel, but I don't want to turn off my brain when it comes to considering unusual applications of the material.
I mean, I know you're not going to IBS, but I'm going to leak it out. I'm going to give a presentation there on kind of the different uses or kind of out-of-the-box uses of Huber products.
Mm-hmm.
Right? I mean, there's been many times I've had to go to Chris Vegas and say, can I use your material like this? And they're like, we never even thought of that.
Oof.
And it's like,
and he probably goes and asks Danko.
Yeah, and it's like, well, there's not a problem. I mean, it meets the metrics of what the requirements are for building science in that assembly.
Mm-hmm.
So, we don't see a problem. We just never gave it much thought.
When you have that long of a span and you're putting up the interior partitions afterwards, has applying a structural sheathing to the underside had any impact on what that bottom cord needs to do? Did you still put like sliders?
We put those slider, I forget the name of them.
I'm just, basically it's a little slotted attachment so that as the bottom cord flexes up and down, it doesn't destroy the
it's only 22 feet.
Yeah.
So this one we're really not concerned about that much.
Interesting.
But we need to, as an industry, I think we would get a lot further if we stop placing these labels and I use Zip because you're sitting here, but it could be a Sega product, a Dorkin product, Benjamin Obdike product. Stop thinking of them just because they designed it to do this one thing. It's okay.
Right.
But like Home Slicker has a bunch of properties, right? It displaces materials a quarter of an inch. It has draining capability. It has drying capability, and it has a certain crushing strength.
Yep.
So we need to think of things in those metrics, not, here is a vented rain screen that's made out of plastic.
Well, and Steve, because you started your career with Building Science Corporation, that's a large part.
It forced me to think a lot differently.
Yeah.
Yes, and I'm trying to put that into, you can't get the old horses to come and drink, but hopefully I can catch some of the younger horses to come to the trough and drink.
Well, and we just need people to think kind of outside the box like you're talking about here. The issue is there's so much tied to everything needing to be approved by somebody else that people hesitate to do this. They forego their knowledge, their experience, and instead of just taking a step back and looking at it like you're suggesting and like you've done, it's okay, well, this is an exterior sheathing product. There's no way I can use it any other way. And in reality, when they call us and ask us, the only data and the information we have also supports that. So they want, it gets a little
as a company, you have to respond inside the limits of your warranty, your promise, your testing, all of that. I fortunately can go total maverick and do whatever the hell I want with your material.
So can other people, right? Yeah.
So the last thing about this question was, and I think pretty clear what the answer is, Did you do that? Would you do this any differently in a different climate?
No.
Right, because you got the air barrier you needed, which you would need in any climate.
Mm-hmm. Yeah.
So the vapor permeability of that particular sheathing has nothing to do with this particular.
Well, I will lead. Are we almost done?
We are almost done.
Okay, because I'm going to leave a cliffhanger. We're doing another project where we're using zip R sheathing in a very delicate position. That's all I'm going to say. Stay tuned.
Is this a future topic, perhaps?
It's a future topic, future videos, future whole lot of stuff. And I will say, it's a passive house. You
heard it here first. Coming up with Steve Basic. Nick, can't thank you enough for being here and working the podcast with us.
He wants to hear my dad joke.
I did.
I was looking for a little bit more of a transition, but
no, because I really don't have one. I had this joke about a pizza, but it was really cheesy.
All right. Thanks for listening.
I got Snickers from the back row.
Send your questions to questions@theunbuilditpodcast.com.
Yeah. And make sure you comment. Love the dad jokes.
Keep them coming.
Thanks for coming.
Bye-bye.